everyone. Today we're going to continue on with Chapter 7 and we're going to go over Section 2, which is about ionic bonds and ionic compounds. It begins with giving an example of an ionic compound. Sodium chloride, or also most commonly known to you guys as table salt, is considered an ionic compound because it consists of sodium cations and chloride anions. To define ionic compound, you would define it as a compound that's composed of cations and anions. This is why it was so important in Section 1 to teach you what a cation and anion are and for you to be able to find charges of different elements. Let's review. As a general reminder, cations are going to be positively charged, and these are going to be mostly composed of metals. Anions, on the other hand, are negatively charged, and these are going to be mostly nonmetals. If we go back to our example of sodium chloride, sodium are cations because when sodium forms its ion, it forms a positive +1. Chloride, on the other hand, is an anion because when it forms a -1 charge. So what is the electrical charge of an ionic compound if they are composed of these ions that have charges? So, although they are composed of ions, ionic compounds are actually electrically neutral, which means that they have no charge. Why is this? They're made up of something that's positively charged and something that's negatively charged. Well, the reason is that positive charge actually equals and balances out the negative charge that the anions provide. So again, positive and negatives cancel. So what holds ionic compounds together? The anions and cations, because they have these opposite charges, they love to attract. Hopefully you think back to integrated science. Opposites attract, like charges repel. So this positive and negative attract each other in something called an electrostatic force. The specific name for the electrostatic force that holds ions together are called ionic bonds. Typically, these bonds occur between a metal and mostly a nonmetal. The reason for this is because most metals form cations and most nonmetals or metalloids tend to form anions. A good example of this, if we're looking back at what we started with, is that sodium chlorine example. When sodium and chlorine react to form a compound, what happens is the sodium gives up the one valence electron that it has, and it transfers and gives it to chlorine because chlorine wants it. Remember, sodium is willing to give up the 1 because it's way harder to try to take 7. Chlorine, on the other hand, it has 7 already, so it's easier to gain 1 than give up the 7 it has. It's kind of like, I'm stronger, so I'm going to take the electron away from you. When they do this, they form a bond between each other. One gets a positive and one gets a negative, and they form salt. Sodium and chlorine atoms combine in a way that there is a 1-to-1 ratio, which means sodium gives up 1 and chlorine takes 1. When we look at the electron configurations, let's review our octet rule. Our octet rule means that we want to form the same electron configuration as a noble gas. We talked about how sodium would form close to neon. It would be 1s2, 2s2, 2p6. Chlorine, since it gains 1, it would be the same as argon. Here's another example of an ionic compound that forms. Aluminum, which is a metal, and bromine, which is a nonmetal, can react violently to form something called aluminum bromide. The chemical formula for aluminum bromide is AlBr3. The way they got this chemical formula is they looked at the charges. So aluminum is a 3+, bromine is a -1, and what they did was they crossed these charges. They brought the 1 down here and it's understood, so they didn't write it. And then they dropped this 3 down here, and that's how you got the 3 down here on bromine. Each bromine has 7 valence electrons, so each one, since I have 3 of them, are going to take 1 from aluminum, the other one's going to take the second one from aluminum, and the last bromine is going to take the 3rd electron from aluminum. So that way that they balance out. 3 bromine atoms will always combine with each aluminum atom. What I just wrote down, AlBr3 and NaCl, these are examples of chemical formulas. I'm going to go ahead and star this because this is important and I'm going to ask it on your test. Chemical formulas show you the number of each atom that is present. So it shows you 1, the type of atom, and 2, the amount. If you look at this chemical formula down here for salt, this has 1 sodium and 1 chlorine. If we look at let's rewrite that, AlBr3, this has 1 aluminum and 3 bromine. The other thing I want to point out is this always happens in the smallest representative unit, which means these numbers down here are reduced to the smallest they can be. A chemical formula of an ionic compound refers to the ratio known as something called a formula unit. Like I just stated, ionic compounds, their subscripts are written in the lowest whole number ratio, and that's considered your formula unit. For example, if you had something like Mg2O2, this would be reduced, because both of these are divided by itself, to MgO. If you had something like, Pb2S4, these could be reduced to PbS2. All it's saying is to reduce your subscripts. So for sodium chloride, the lowest whole number ratio that it reduces into is a 1-to-1. There's 1 sodium for every 1 chlorine. Now, although ionic charges are used to derive the correct formula, they're not shown when you write the formula unit, which means you don't bring down that negative and you don't bring down that positive. Before we start doing a couple examples, I want to go back over some relevant concepts. Remember, atoms of metals tend to lose valence electrons, nonmetals tend to gain, and then there has to be enough of each element so that their formula is going to be neutral. That means that the same amount of electrons have to be the amount of electrons lost has to equal the amount of electrons that are gained. So let's go through 3 examples. We're going to use electron dot structures to predict the formulas of the ionic compounds formed for the following elements. We're going to work on potassium and oxygen, magnesium, nitrogen, and calcium, and then fluorine. First off, this is not in your notes, but I love to ask these questions, and they'll be asked in your homework on Friday, so you need to be able to answer them. The first one, you should be able to tell me, if I give you 2 atoms, which atom loses, how many electrons that it lost, and what its charge would be. You should also be able to tell me what atom gains electrons, how many are gained, and what would be the charge. And then I'm going to teach you how to write a chemical formula for it. Please note that I tell you to write the positive ion first and the negative ion right after it. Let's do the couple examples. First, we have potassium and oxygen. Out of these 2, you should be able to tell me which atom loses. Well, remember, the ones that are going to lose tend to be metals, and that's going to be potassium, which is K. Well, you have to see how many are lost. Well, potassium belongs in group 1A, so it loses 1. And then what is its charge going to be? Well, its charge is going to be a 1 plus, or a plus 1. Well, which atom gains electrons? That's going to be your oxygen because it's your nonmetal. How many are gained? Well, you need to look at the group. Oxygen's in group 6, so it's easier to gain 2. The resulting charge for that then would be a 2 negative. When you go to write the chemical formula, I highly suggest on the side you write your 2 symbols, +1, oxygen, 2 negative, and then what you need to do is you need to cross them. Here, the 2 would come down on the K, so K gets written first because it's positive. The 2 comes down here, and then down here you write the O, and then a 1 comes down. You can write a 1 or nothing, it's just understood. The reason I have you write your chemical formula is because then it helps you draw it a lot simpler. This tells me when I draw it that I need to draw 2 K atoms. So K, K, and then I have 1 oxygen. Then we need to do the electron dot structure. So potassium has 1 valence electron, so I draw 1 dot around each one. Oxygen, how many valence electrons does it have? Well, it has 6 of them. So 1, 2, 3, 4, 5, 6. Once you've done that, you need to draw, well, what happens during a reaction? Well, what happens is potassium likes to lose it and give this one to oxygen. This potassium will lose it and give it to oxygen. So now that oxygen has 8 total valence electrons, and therefore it's happy. Let's try another example. You have to ask yourself, out of magnesium and nitrogen, which one is going to lose electrons? Hopefully you told me magnesium because that's the metal. And you can say, well, how many are lost? Look to see what group it's in. It's in group 2, so it's easier to lose 2 than gain 6. So if it lost 2, what would its charge be? Well, it would be a 2 plus. That means that nitrogen has to be the one that gains, and it makes sense because it's my nonmetal. How many does it gain? Well, it's in group 5, so it's easier to gain 3 to get to 8, and its charge is going to be a 3 negative. From there, we have to derive the chemical formula. So you have Mg2 plus, and you got N3 negative. We have to cross our charges. So Mg gets written with a 3, and that 3 is a little 3. N gets written with a 2. So N gets a little 2 down here, and therefore, then you can check to see if you need to reduce, and you don't, so you were done. Now we have to draw our structure. This tells me that I need to draw 3 magnesium. 1, 2, 3. And then I need 2 nitrogen. Remember, electron dot structures, you draw the valence electron. So magnesium has 2 valence electrons, so each one gets 2. Nitrogen belongs in group 5, so it should have 5 valence electrons. And then what you do is you're going to draw the arrows. Here, this one could go here on nitrogen. Oops, did not draw. This valence electron can go here, and this one up here can go over on this side. This would give nitrogen 8. Over here, this valence electron can go here, this one can go here, and this one can go here to give this nitrogen 8. And our last example, calcium and fluorine. Well, which one's going to lose? Look for my metal. My metal is going to be calcium. It's going to lose 2 because it's in group 2. The resulting charge would then be a positive. The one that's going to gain is going to be fluorine. That makes sense because it's my nonmetal. It's going to gain 1, and the charge is going to be 1 negative. So when I write my chemical formula, make sure that you write your charges and then cross them. Here, a 1 is going to be crossed down on calcium, and I can just leave it blank. On my fluorine, My 2 is going to be dropped down. Please note that 1 and 2, you cannot reduce that, so you are good. This tells me that I need to draw 1 calcium and 2 fluorine. Remember, the dots are how many valence electrons it has. So calcium has 2. Fluorine has 7 each. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then you just kind of draw your arrows for where they need to go. This calcium goes here, and this calcium goes here to make sure each fluorine has 8 valence electrons. So what are some properties of ionic compounds now that we've learned about them? Well, there are 3 properties of ionic compounds. The first is that most ionic compounds are solids at room temperature, and a lot of them form crystals. These crystals tend to be repeating 3-dimensional patterns, and they have a pretty orderly arrangement. Now, each ion is super strongly attracted to its neighbors, and so therefore, that's why they tend to form these solid crystal structures, and they're actually very stable. The second thing to note is ionic compounds have very high melting points. You have to increase the temperature to be really high to turn these into liquids. And the last one is ionic compounds love to conduct electricity whenever they are melted or put into water. So that is why if I melt salt or if you dissolve salt in water, it's very conductive. They tell you that do not put anything electronic near water is because water tends to have impurities in it, or basically compounds that are breaking down of ionic compounds. So when sodium chloride is melted and broken down, if I hook it up to a power source, an electric current will flow through this water and complete a circuit. So if a voltage is applied, cations migrate from one end to the other through the water, and it completes a circuit. Here's a good example of a solar facility that's actually using molten or basically melted salt to absorb heat and use it for electricity. So again, ionic compounds can also conduct electric current if they are dissolved in water, and they do this because those ions are free to move about in the solution. And that's the end of my lesson. Let me know if you have any questions, and I'll be more than happy to help you. I hope you have a great day.